Hello students, in today's session of nuclear physics, under the chapter Nuclei, further very basics will be cleared through illustrations. In earlier session, we have gone through mass defect, binding energy through illustrations taken from JEE Main, which you can review on YouTube channel Satisfied Club. In today's session, we are going to discuss what is mass defect, mass energy equivalence relation, mass energy equivalence, nuclear fusion, effect of alpha decay, beta decay, and other number of topics. It is requested, please go through the session completely, being very important for CBSE board, state board, this, and other entrance examinations. Now, let's start with the question. In the nucleus of helium, if F1 is the nuclear force between two protons, F2 is the force between two neutrons, and F3 is the force between a proton and neutron, then four options are given to you. One of the options is correct. Concept, applicable, and solution. F1, F2, F3. F1, two protons, force between two protons. Between two neutrons, and between neutron and proton. We have to pick up one of the correct answer in terms of inequality. Proton is a positively charged, electron is a negative charge, neutron is no charge, neutral, right? Concept applicable. What is nuclear force? In nucleus, the positively charged protons and uncharged neutrons are held together in extremely small space of the order of 1 Fermi. In spite of the strong electrostatic repulsion between protons, obviously there are some strong attractive forces operating within the nucleus between the neutrons, known as nuclear forces, which are short-range interactions which extend up only about 2 Fermi. In contrast, electrostatic interaction is long-range interaction. Nuclear force is essentially same for all nucleons and is independent of charge. That is, nuclear forces between proton and proton, neutron and neutron, between neutron and proton is same. That is, it is independent of charge. Nuclear force is applicable equally on all nucleons. In this sense, the correct option is A. A is the correct option. A is correct option. Right. Next question. Question is binding energy per nucleon versus mass number curve for nuclei is shown in the figure. This is the curve. For W, X, Y, and Z are for nuclei indicated on the curve. W, X, Y, Z. The process would release energy is, out of 4 options, one of the options is correct. Concept, applicable, and solution. Concept, applicable, solution. Binding energy. What is binding energy? This is the energy required to completely separate the nucleons. Nuclear binding energy equal to delta m c square. C is the velocity of light. Delta m is the mass defect. What is mass defect? That is ZMP plus A minus Z, mass of proton, mass of neutrons minus mass of the nucleus. This much mass is lost during the formation of nucleus. If there is increase in energy, then the process is possible. The process would release energy if. Now, let's see. First option, W, Y, X की वैल्यू निकाल लीजिए, Y की वैल्यू निकाल लीजिए. W की वैल्यू निकाल लीजिए, Z की वैल्यू निकाल लीजिए। X की वैल्यू आई 90 into 8, that is 720। Y की वैल्यू निकाल लीजिए, Y की वैल्यू 60 into 8.5, that is 510। W की वैल्यू निकाल लीजिए, W is 7.5 into 120, that comes out to be 900। and Z की वैल्यू निकाल लीजिए, that is 5 into 30, that is 150। यानी टोटल एनर्जी will equal to the binding energy per nucleon into number of nucleons, right? Y is 510 to Z, 2 into 150, that is 300. So there is decrease, not possible. W is 900 X plus Z, 720 plus 150, that is 870, that is decrease, not possible. While W 900 to Y, 2 into 510, that is 320. This is increase. And in this case, X, what is that this answer is possible? This is not possible. This is not possible. X is 720, Y plus Z, 510 plus 150, that is decrease. This is also not possible. So process would release energy is in the case of C part. So option C is correct. Option C is correct. Option C is correct. Right. Next question.
Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very helpful and useful, which you can review on YouTube channel Statistics Learn. In addition to this, I would like to say that these papers, complete video sessions are available on Statistics Learn YouTube channel, which you can review on Statistics Learn. In addition to this, further, these papers, detailed solution with additional information available on website statisticslearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल Statistics Learn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question.
Question is, nucleus A is converted to C through the following reactions. Nucleus A is converted to B by emission of alpha decay, and B is converted to C by emission of 2 beta decay. We have to pick up one of the correct answer out of 4 options. A and B are isotopes, A and C are isobars, A and B are isobars, A and C are isotopes. We have to pick up one of the correct answer. Concept applicable solution. Classification of nuclei. What is isotope? The elements having the same number of protons but different number of neutrons. That is the isotope. These are the examples. Isobars, element having the same mass number but different atomic number. That is the isobars. And another additional information, isotones, the elements having the equal number of protons, that is A minus Z. 7 minus 3, 8 minus 4, 4. These are the examples of this. And what happens alpha decay? Alpha decay mein, that is the helium nucleus. So mass number is reduced by 4 or atomic number is reduced by 2. Then the alpha decay is there. This is equal to alpha. What is beta decay? Beta decay is of two types, beta minus, beta plus. If in the question nothing is stated, you have to consider beta minus. You have to consider beta minus. Beta minus में क्या है? Mass number is increased by, remains same, and atomic number increases by 1. This is the beta minus one. Beta plus one decay में mass number decreases, remains same, and atomic number decreases by 1. This is the beta particle. Now in this case, we will use these concepts to find the answer. Let's start the question. Now, let's start the question. A to B, Z A. We'll get Z minus 2, B will get A minus 4 plus twice H. Then B, Z minus 2, A minus 4, C plus twice E. So twice minus 1 E, 0. So this will become Z minus 2 plus 2, that is Z, and this will remain A minus 4. Means in case of A and C, atomic number is same. Atomic number is same. Then, and mass number is different. Mass number is different. So what is the definition of atomic number is same? That means has the same number of but different number of neutrons, isotopes. Mass number is different. Then correct answer is D. D is the correct option. Right? Next question. Question is, in the reaction 1H2 plus 1H3 further produce a 2He4 and 1 neutron. If the binding energy of the 1H2, 1H3 and 2He4 are respectively A, B, C in MeV, then the energy released in the reaction is 4 options are given to 1 of option is correct. Its answer can be given in 5 seconds, right? But before giving the answer, I will clear the concepts applicable, right? It is a case of two highlighted nuclei combining. If it is combining, that is the case of nuclear fusion. If two or more highlighted nuclei combine to form a heavier nucleus, this process is called nuclear fusion. Hydrogen bomb is based on this concept. In both the process, whether binding nuclear per nucleon is increasing. That is in case of nuclear fission and nuclear fusion. Fusion में क्या होता है? Heavy nucleus splits into two or more lighter nuclei. In both the cases, energy is released. It means binding energy. It is a case of nuclear fusion. Energy of daughter nucleus should be greater than energy of binding energy of daughter nucleus greater than of parent nucleus. That is B, C minus A plus B. This is the answer. That is C minus A minus B. This is the answer. B option is the correct option. Right? Next question. Question is, which of the following nuclear fragments corresponding to the nuclear fission? It is case of nuclear fission between neutron and uranium isotope is correct. 4 options are given to you, one of the options is correct. Its answer can also be given within 1 minute by calculating the atomic mass number and mass number balancing. Concept applicable in solution. In nuclear fission, a heavy nucleus splits into two or more lighter nuclei of almost of equal mass. Nuclear fission is initiated when a heavy nucleus captures a thermal neutron. That is known as neutron. Atom bomb is based on this concept. And in fission case, if two or more lighter nuclei combine to form a heavier nucleus, this is called nuclear fission. Hydrogen bomb is based on this concept. In both the process, binding energy per nucleon increases, therefore energy is released. Graphically, it is the case of fusion, this is the case of fission, right? Now, come to the question. Now, in this case, 92 uranium 235 plus 0 and 1. Option A, we have to balance mass number and atomic number. In the first case, 234, 92, B option में आएगा, that is 237 and 94. C option में आया 255 and 92. D option में आया 236 and 92. Now, these are the right side options. And left hand side में क्या है 92 and 236. Which is matching, that is the answer. 236, 92, 236, 92. D option is the correct option, right? Now, I would like to request, if you are new to my YouTube channel, Set His Shift Learns, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.